My name is Anastasia. Welcome those guys who are online with us today. So, today we prepared for you an extraordinary presentation. You may ask, what is so special about it? And I'll tell you, this is a new way to present Rosatom's latest modern nuclear technologies, which we are very proud of. And today you're going to see a very special place. This is the place where the future of nuclear energy is being built, where the heart of fast neutron reactors is beating. Our speaker for today is Natalia Tutenkova, a representative of Beloyarsk nuclear power plant. And she came here for you from far, far away region of Russia, from Ural. And I bet she cannot wait to start. But before we begin, a few words of how our session will go. First, you are going to listen to the virtual tour. And after that, you will be able to ask your questions, give your comments, maybe some wishes to Natasha. And we'll do our best to answer your questions. Okay, we are ready to start. Natasha, the floor is yours.
Thank you, thank you. Thank you, Anastasia. Thank you for your interest in breakthrough technologies. And I would like to start with a question. Do you have cars? Yes? Okay. So even if you don't, you know that to get somewhere by a car, you have to fill the tank, yes? You put, it's kind of exchange, you put gas, fuel, or electricity in it, and it moves and gets you to the destination. And imagine after a long month of going places by car, the tank is still full. The car is not just moving, it's refueling itself. It's impossible. But what if I say that Rosatom has built such a machine to generate power? Dear guests, welcome to Beloyarsk nuclear power plant, the only power plant in the world with fast reactors. My name is Natalia, as Anastasia has already said, and I will guide you to the world of fast neutrons. And for a better immersion into the tour, I would ask my colleagues to switch off the light. Yes, I'm some voice in the dark. Okay, so as part of your virtual visit today, you will have an opportunity, you will have an opportunity to get acquainted with the unique commercial fast reactor BN800. We are going to visit the key spots of this power unit, the reactor hall, the turbine hall, the main control room. We will also go to the training center and the town of Zarechny. By the way, we can see the reactor building over here. The turbine hall is to the right, and the main control is between them. But before we speak about advanced technologies, I would like to give you some background. Beloyarsk nuclear power plant was named after Igor Kurchatov, the father of the Soviet nuclear industry. The power plant consists of 4 power units. You can see power units 1 and 2 in this white building. 1 pipe ventilation stack for each unit. And power unit 3 is over here to the left with also 1 pipe. The first unit was commissioned in 1964. The second was put into operation 3 years later. Currently, these 2 first units are shut down and are under decommissioning. In 1980, a third reactor was built at the site. This time it was a new type of reactors, a fast sodium-cooled reactor with a capacity of 600 megawatts. It was called BN600. BN600 became a prototype for the most powerful fast reactor, of course, in the world, BN800. power unit startup took place on the 10th of December 2015. Its design service life is 40 years. These days, the unit is operating normally, generating 880 megawatts of electricity. So let's learn more about this unique reactor. And we are going to the administrative building. Here it is. This is the starting point for all excursions, virtual and real ones. The reactor mock-up is located here, as is the unit heat flow diagram. And by the way, my office is also in this building. So, BN 800 replicates the design and technological achievements of BN 600, its predecessor. And in line with the current trends, it incorporates a number of additional passive safety systems. These systems do not depend on humans or automatics. Emergency air cooling system is among them. Do you remember I showed you the first 3 units with 1 ventilation stack for each? And on top of the BN 800 reactor building, you can see not 1 but 4 ventilation stacks. 1 is traditionally used for normal operation, the other 3 form this emergency cooling system. It works by natural air circulation through heat exchangers. Even without electricity, heat will be removed from the reactor. Another innovation is the emergency shutdown system. Can we go to the questions after the tour, please? Yes, thank you. Okay. So, emergency shutdown system. It consists of rods floating in sodium. When circulation pumps are in operation, sodium flows upwards the reactor core and keeps these rods on top like buoys. You can see these golden rods here. Should the sodium circulation cease, the rods will drop into the core and stop the nuclear reaction. And this device at the bottom of the reactor vessel is a core catcher. In case of the most improbable and fantastic accident involving fuel melt, it will retain fuel and prevent further reaction. All these systems increase the reactor safety. But why are fast reactors not just a safe and effective way to generate power, but a real scientific breakthrough? People cherish a dream of an unlimited energy source. The nuclear industry is getting closer to this dream with its new technological platform based on a closed nuclear fuel cycle. And here fast reactors appear. As other reactors, power reactors, BN 800 generates heat and power. But only fast neutrons can make use of uranium-238. This isotope represents more than 99% of natural uranium. These are huge energy reserves, but they are not used today because reactors cannot digest them. What's more, fast reactors can operate on unburned fuel from other reactors, thus reducing waste and producing new fuel. And I can't help but add some advantages of fast reactors. They are also one of the most environmentally friendly reactors. They contribute to the environment by 0 carbon dioxide emission. So I think it's the right time for us to go and see the pride of Beloyarsk nuclear power plant itself. We are on a special deck for tour groups with a great panoramic view of the reactor, so I offer us to take this advantage and have a look around just for a moment. Here it is, the reactor. Our employees often call it an octopus. You can see its orange body and silver tentacles. Actually, these are sodium pipelines, and this is a reactor protective hood. The reactor itself is 16 meters below. As you know, during the nuclear reaction, a lot of energy is released. That is why in the reactor the temperature is very high. To control this temperature, reactors use coolants. Most reactors in the world use water for this purpose, but BN 800 uses liquid metal, sodium, This choice may seem surprising. Meanwhile, sodium is much safer and more efficient in many ways than water. It will never boil, not in our reactor. It doesn't corrode metal parts, it imposes operation at low pressure, and it conducts heat well. But the main fact is that sodium doesn't moderate neutrons, so they lose less energy than in water and remain fast. That's how they can involve uranium-238 into fission process, and as we have already discussed, that can significantly expand the fuel base for nuclear industry. And in this picture you can see the moment when in 2013 2,000 tons of sodium arrived at BN 800. Let's go upstairs and see the reactor from the point where no real tour group has ever been to. I must also add that neither have most employees. Under the orange protective hood, there are sodium pumps, intermediate heat exchangers, reactor control and safety system, and refueling system. Yes. The compact core is inside the reactor. It is formed by fuel assemblies, long hexagonal rods. Each fuel assembly contains a bundle of fuel pins or rods with nuclear fuel pellets inside. Unfortunately, the only way to see what's going on inside our reactor is with computer graphics, so let's do it right now. The reaction starts inside fuel assemblies. You can see them here. When neutron hits uranium nucleus, it splits into fragments and forms more neutrons. Because during this process a lot of energy is released, the fuel pellet heats up. High thermal capacity of sodium prevents the reactor from overheating. To make the reactor even safer, radioactive sodium flows only inside the reactor, and the steam goes to the steam generator, the heat goes to the steam generator with through intermediate heat exchangers. You can see them on the video. Sodium circulates in 3 loops, and each loop can work independently of the others. Nuclear power of the future will be represented by a dual component system. This system will include thermal and fast reactors joined with a closed MOX fuel cycle. So it will be more like 2 cars refueling each other. MOX fuel is a mixed oxide fuel, and MOX pellets for BN 800 contain plutonium oxide produced by power reactors and uranium oxide. It is so-called enrichment tailings or enrichment wastes. The BN 800 core was hybrid at the beginning. During the startup, it was partly loaded with traditional uranium fuel and partly with experimental MOX fuel. Step by step, we convert the reactor to MOX fuel, and in this video, you can see the MOX fuel being loaded into the reactor in January 2021, a year ago. And the last refueling campaign was completed about a month ago, the latest, not the last yet. The latest campaign refueling completed about a month ago in December, and since then 2/3 of the core are operating on MOX fuel. Why I'm so excited about 2/3? We know that because when the full-scale transition happens, this will be a step towards closed nuclear fuel cycle. BN 800 was designed to master new technologies. It is attractive but challenging at the same time. Safety is our top priority, and we strive to comply with international and Russian safety standards. And we confirm this compliance through numerous inspections and reviews. But it's time for us to go to the next point, to the turbine hall, and follow the heated sodium. Now we are in the turbine hall where electricity is generated. Usually there is a lot of noise here due to the working equipment. We're lucky not to have it on the virtual tour. As you can see, there is nobody here at this moment. We didn't evacuate people to take this picture. The thing is that most processes are automated or remote, so the field operators go to check the equipment only every 2 hours. So we can say that empty halls mean smooth and flawless operation of the plant. When heated sodium leaves the reactor core, it comes to the turbine hall and gives heat to water in the steam generator. That's why the water turns into steam and goes to the turbine. The turbine occupies almost the whole hall. You can see it here. Just to get the idea, imagine an airplane, to be precise, a model Boeing 737 with its engines running, the same size, the same noise. And in the next video, we are going to see what happens inside the turbine. When steam passes through pressure cylinders, it pushes to turbine vanes. The turbine rotates itself and rotates the alternator. And there, the mechanical energy is transformed into electric power. So finally, we have electricity. Going back to the airplane. Think back of a time when boarding the airplane. Its engines are running, you feel the vibration, and because of the noise, you can hardly hear other people. Yes? So I remind you, we have a Boeing 737 in our turbine hall. Its engines are running. And I want to show you one more video where a senior turbine operator puts a 25mm coin. I will show it to you closer after the tour. He puts it on its edge on the turbine, on the working turbine. So let's see and watch the coin. The coin doesn't fall over. You cannot hear the sound, the noise, but you have to imagine it like an airplane. So I can hardly put this coin on its edge on a flat steel surface, which is not moving or rotating some mechanism inside. So you can try to do it after the tour. Maybe you will be lucky to do it. And now imagine the coin on the wing of the working airplane. Not flying yet, but it's still at the ground. So you see that despite its incredible size, the turbine rotates smoothly without excessive vibration. But let's get back to electricity. Here we see a switchyard. Here the transformer steps up the voltage and the electricity, the power is transferred to the grid. There it is distributed among consumers, industrial enterprises, and households. So that's the process of our power plant. So now you know how the electricity is generated and our turbine hall works. Previously we met the reactor with its systems, but who controls the whole process? Let's go and see the heroes. Now we are at the main control room, or MCR, the brain of the power unit. All technological processes are controlled here, from nuclear reaction, heat transfer, water heat, to alternator rotation. But I invite you to go back again for some historic moment which took place in this room. Look at this picture. It shows us a great moment for Beloyarsk nuclear power plant, and in my humble opinion, even for the whole nuclear industry, connection of power unit 4 to the grid. Remarkably, the first megawatts of electricity were transferred to the grid at 21 hour, 21 minute, 21 second. It was mere coincidence, but we were lucky to capture this moment. Let's get back to the present. The main control room includes workstations for senior operators, department shift supervisors, and the main person here is power units for shift supervisor. In front of you, you can see a large screen display. It shows the diagram of all equipment and systems at the plant and their status. But in my opinion, the best place at the MCR is here. Just a moment, not here yet. Yes. Now we are behind the shift supervisor's back, and we have a chance to see the MCR the way he does. You can see that he has an overview of all operators and all monitors. From his workstation, shift supervisor can assess the state of the entire power unit. To become a shift supervisor, one must get a field-specific degree, study a lot, and pass many exams to get permission by Russian regulator. This is a critical job, so it requires a lot of knowledge and experience. And these are only 10 minutes of MCR non-stop operation. Imagine the responsibility these people take on. In order to respond to any issue, they must be professionals, have good health, and be well trained. The operating personnel receive ongoing training at the training center. So I invite you to go and watch, see how it happens. No matter how high-tech the plant is, its main value is in people. More than 2,500 people work at the Beloyarsk nuclear power plant. In these classrooms, they study occupational safety, radiation protection, fire safety, and other work-related subjects. For the maintenance personnel, the training center provides classrooms with equipment mock-ups, and for operating personnel, analytical simulators are used. But the gem of the training session is the full-scale simulator of BN 800. But before we look at it in details, I would like to show you two pictures. One of them shows the real main control room that we have visited already. The other is the full-scale simulator. So I invite you to look at these pictures and guess where the simulator is. Okay, maybe we should vote. Please raise your hand if you think that the simulator is in picture one. One, yes, one. To the right, to the left. Okay, and those who think that the simulator is in picture two? Oh, good job. Yes, that's the simulator. Actually, I've been to both places, but I can distinguish between them judging by the uniform the operators wear. Well, yes, as well. Thank you for this remark. So you see that the simulator models the main control room in details. The actual equipment is replaced with the software, and it models how all systems and mechanisms respond to the operator's actions. Here, operating personnel practice operation under normal conditions, any equipment or system failures, as well as design basis and even beyond design basis accidents. And here are only a few examples of scenarios. If we put all the scenarios the operators train, practice, that would be even, yes, that's right. Some of these situations are highly improbable in our region, earthquake or tsunami or whatever, something like this. But our operators have to know how to handle it, and they do. So, we know how the plant operates, and we also know now how the personnel is trained. So I invite you for a quick tour around Zarechny, a satellite town of Beloyarsk nuclear power plant. Just a moment to turn the panorama. Okay. Nothing to compare with Dubai, of course, but still, it is a small but beautiful town. More than 30,000 people live in Zarechny. Beloyarsk nuclear power plant is a town-forming enterprise, so its future is associated with the life of the town. Rosatom pays special attention to development of towns where its nuclear power plants are located, and Zarechny, with the help of Rosatom, has built many important facilities. They include residential blocks, kindergartens. I will show you just a few examples. Cathedral, cinema, and many other places for citizens. For example, this is the Boulevard, one of the most favorite places. Many other facilities have been renovated. For example, this is a swimming pool. For the population of 30,000 people in our town, we have an international standard swimming pool, and a lot of regional and even national competitions are held here. To tell the truth, Zarechny is not my native town, but when I first came there about 10 years ago, I couldn't believe my eyes. It's not just to impress you, I really couldn't believe my eyes. It was a small but a very beautiful, clean and developing town. 10 years have passed and now it is even a better, prosperous place which didn't lose its connection, its bond with the nature. And at this point, I would like to come back to the main panorama. Step by step, we move towards our goal. BN 800 reactor has been built and commissioned. Now we're converting it to MOX fuel. In the future, we are going to close the nuclear cycle, thus making the nuclear energy technically renewable. This is not utopia, just a hard work and patience. Dear guests, today we took, I hope, an inspiring tour around the Beloyarsk nuclear power plant and its advanced power unit with BN 800 reactor. The tour itself is over, the virtual part of it, and I would like to say that we'll be happy to greet you at our site and show you the reactor in real life. Thank you for your attention. Anastasia, can you join me? Can you please switch on the light?
Yes, colleagues, please switch on the light.
Yes, thank you.
Okay, Natalia, thank you very much for your such inspiring presentation. I hope that everybody has liked it, and now we can talk a little bit. You can ask your questions, maybe some comments, wishes, but or I give you an opportunity to raise your hand, and ask a question. We actually got 2 questions from YouTube channel. Number 1 is, what is the TMCR for BN 800? Turbine maximum circulation rotation. So we had an opportunity to, contact our experts from Beloyarsk and PP. So the answer is that turbine can work on such maximum rotation for about half a year, and after that it will go to the maintenance works. So some maintenance works will be done with this turbine. And BN 800 is generating, so the question was, I heard it is generating 890 megawatts now, so it's about 880.
Well, I left Zarechny a few days ago. Yes, and this power rate is a bit different. It can be different
so
a
it
little.
changes. Good. And the next question was, any news on BN 1200 project? When do you expect to receive the construction permission? Well, actually, all the work that is done about BN 1200, it's in development, in design, Yes, we have it in the Russian roadmap that, has big plans up to 2050. And our colleagues, they, told us that maybe in 2030s it will be possible to start.
Oh, yes,
working on
thank you
it,
for
yeah.
this. Just to give a quick remark.
Okay.
It is planned, it's on the project, but we cannot be sure when and what will happen.
Yes, of course.
And
it's
just
on
for
the
those who maybe don't know, BN 1200 is going to be a fast reactor, on sodium-cooled reactor, which will generate 1200 megawatts.
plan. About, yeah.
And it is planned to be a serial reactor, not experimental demonstration and so on, but a serial one.
Yes, yeah. So maybe you have questions, you can raise your hand. Colleagues, can you give the microphone to ask the question, please? Or I can give you mine.
Oh, yes, of course.
I think I can use this one.
Okay.
Yeah. Thank you very much for the nice presentation. Actually, I was born in Yekaterinburg and spent first 20-something years of my life there. And just on the opposite side of the lake, of this artificial lake, there was a touristic base of optical mechanical factory where my mother lived. So my mother worked. So I was often go there and see over the
Spectacular view, yes?
over the lake. The first two, it was long ago. It was only first two. Yeah, but
units.
BN 800 was under construction at the time. Yeah. And I have two questions on the BN 600 was under construction. On BN 800, this passive coolant system, it's cooled sodium or water, the third circuit?
It cools the reactor.
Reactor itself.
Yes. It removes heat from the reactor.
From the reactor vessel. And the second question, how do you prevent incident like on Monju, when sodium was just leaked for a few days before it was noticed?
Oh, thank you. That's a good question. Yes. Very good question, really. Because, yes, sodium, especially radioactive, can have reaction with the air, but we have special systems that can detect sodium leakage even at the stage where it doesn't leak. No, it sounds like magic, but it really happens like that, if to put it in simple words. So the special detectors, they can see if there is some problem between the welding parts, something like that, and it can understand if there would be some leakage. So some maybe really not even a drop, but I don't know, maybe some particles, fractions of it. So really, this detecting system works. The pressure in the sodium circuit, yes. I cannot tell you for sure.
We can, yes, we're not technicians, unfortunately, or right now, luckily, but we can contact our colleagues later and, well,
Yes.
yeah,
But the
find out
reactor
the
is
number.
not pressurized. Oh, yes, a bit over the atmospheric, so it is not pressurized, that therefore the construction is a bit different.
Thank you. The first question is, you said you have a core catcher.
Yes.
If the BN 600 has a core catcher too, it's new addition or new improvement of the design. That's the first question.
Yes. Okay. To tell the truth, I'm not sure about it. I know
there was no core catcher in the BN 600.
there was no in the project now.
Yeah. Okay.
Because I'm just doubting, because after the Fukushima events, some systems have also been changed at BN 600.
Yeah.
So, yes. But not a catcher. Yes, not initially.
And
not
the second
initially.
question about the shutdown system.
Yes.
See, you have only road shutdown system. Do you have any alternative emergency shutdown system?
I just told about the passive system. So it's it doesn't depend on automatics or human. Of course, there is a controls safety system which can be operated by the operating personnel, or it works also by automatics. Yes, but the rods they work just by laws of nature. So
Yes,
they
drop.
they drop. There is nothing that keeps them on top. They drop and they cease the reaction instantly.
It's totally passive. So they work. They are lifted up by the sodium counter flow, and when flow stops,
It went down by gravity.
Yes, by gravity.
And
We,
the
we
last
have an
question-
expert here.
Thank
The
you.
last
You're lucky.
question, I assume you had a very good lesson learned from Phoenix and Super Phoenix in France.
Oh yes.
Where really it was, the use of the sodium was prescribed after this one, and nobody used it except in Russia.
We are
I-
proud of it. Yeah.
I think you made a great achievement because you proved that the sodium, liquid sodium is very good for a fast breeder reactor.
Yeah, thank you.
Thank you
I,
for the
I
presentation.
will share this word with our chief engineer and his team. They will be very proud of it. There was a question there over there. Yes, can you pass the mic, please?
Thank you very much for your very nice presentation. Just curious question: during the refueling, sodium is still hot, or how it is going? The
Well,
refueling
yes.
process when you not you but your
Yes.
your colleagues change the fuel. Sodium is not in the reactor, yes?
Sodium is still there,
in the
yes.
reactor. Ah, okay, so it's still circulating and it's with hot
I'm not
temperature.
sure, but maybe the pumps are not in operation because there is no need to transfer the heat because the reactor is shut down for a
Yes,
refueling
okay.
campaign. So I don't think that it circulates like that, but it's still there. Some amount of it is still there.
It's liquid or not?
They do not drain it from the.
But
It's
is the-
liquid. It can
it's-
it can stay in the reactor like that for a few days.
Ah, okay.
So no problem.
Okay, thank you.
As Anastasia said, I'm not a technician as well, but I asked that question. So
Yeah. If you really want to find out, you can contact us later. We will be very glad to contact our experts and give you
No,
all the information.
It was my question. One day I asked this question: do they drain sodium somewhere during the refueling campaign? No, they don't. It's still in the reactor.
Okay, and is it a big problem if the sodium will be solidified for, I don't know, for some reasons? If the refueling process will take a longer time than it was scheduled and sodium solidified, so become a solid,
Well, I
is
think
it a
yes.
problem to melt it again or not?
Thank you for this question. I'm not sure about the melting point of sodium. I studied this question, but it is not very high.
It's not very high, absolutely.
So-
If the operational
But I
temperature
cannot
is around
imagine it's
300
solidified
degrees,
in
but
the reactor.
still you need to melt it somehow. I don't know. That's
So unfortunately, I cannot answer this right now. But if you're really interested, we can ask our colleagues right now online. So just a few moments later, we will give you the answer. Less than 100 degrees. Thank you. You're my expert here. And there was also a question. Yes.
Thank you for a nice presentation. It was very pleasant for us, of course. I have one technical question. Technically speaking, it is possible to use spent fuel in the fast reactors. Do you have experience any with spent fuel or use only the fresh one?
You mean? I just can't hear.
Can you repeat this?
Spent
again,
fuel in
okay.
fast reactor again.
Yes, okay, because there is enough uranium to 38. But is it necessary to process it before use in the reactor
Oh,
again?
yes, I get the
And
question.
do you have any experience in this area?
So thank you for this question. We personally, our plant doesn't have this experience, but there are factories in Rosatom in this circle, in this company that reprocess. So the MOX fuel, it is actually made of plutonium oxide from power reactors, so it has already been reprocessed.
Okay, colleagues, more questions? Okay, I think that's the time when we can
Yes, just
finish.
if you have some
Yeah.
questions a bit later, we're still here. You
We
can
are
come
here,
after the
you
session.
can contact, leave your contacts. We will contact our experts and we'll be happy to again hear your comments, questions after our session. So again, thank you very much for your attention, for being here with us. Hope
for
to
your
see you
questions.
someday at Beloyarsky PP. Thank you.
Thank you very
Goodbye.
much. We know that you spent here a long time. We appreciate your staying with us.